Sa sino ka ba? Mayroon bang Pinoy na kasing galing mo? Sino ka ba? Sa sino ka ba? Mayroon bang Pinoy na katulad mo?
Is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa teleradyo. Please take time to send your feedbacks via Teleradyo Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow bit.ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradyo Mu, kung saan ang feedback mo, suggestions nyo ay mahalaga sa teleradyo.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kaakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo.
Good afternoon, grade 10 learners. We are now live here in our Teleradyo Marcelo, ang telearalan ng bawat Maloleño. Again, I am Mrs. Jenny Tidaregla, your teacher broadcaster for today. I am going to discuss about probability of union of two events. The objectives are illustrate probability of union of two events, solve the probability of A union B, differentiate mutually and not mutually exclusive events, and solve problems involving mutually and not mutually exclusive events. Let us have a review first. Using the given Venn diagram on the right, so kindly answer the following. So what is the set of elements of A? So you may type in your answer on the comment box for you to recognize. So what is the set of elements of A? Again, what is the set of elements of A? Okay, so the set of elements of A are A, E, F, I, K, M, and then letter O. Those inside circle A. Set of A union B. So what is the set of elements of A union B? So the set of elements of A union B, okay, so A, B, E, F, G, H, I, K, M, and then O. So those are the letters inside the circles A and B. Okay, so your answer are correct. Next, what is the probability of A union B? What is the probability of an event A union B? Okay, so the probability of A union B is equal to 10 over 15 or 2/3. Since our A union B has 10 letters and then our sample space is equal to 15, so all letters inside the box, so sample space is equal to 15, so 10 over 15 or 2/3. Okay, so Kayla Balatbat, Nico Rice, and Yuchonko got the correct answer. And Yvonne Yamani, Lexin, Kiel Apostol. Okay, thank you for your answer. Next. So from the same Venn diagram, so what is the set of elements of A? So ulit. Ito yung kanina. Next. What is the set of elements of A intersection B? What is the set of elements of A intersection B? So the set of elements of A intersection B are letters MOE or EMO. Next. So what is the probability of A intersection B? What is the probability of A intersection B? So probability of A intersection B is equal to 3 over 15. So since the letters inside the intersection between A and B are EMO, so we have 3 letters over 15 as the sample space. Or in simplified form, the answer is equal to 1/5. Okay, correct. Seth, Aliyah, Rieza, Lordan, Lexin, Yvonne, Melissa, kay Miranda, Joy K. So correct. Next. What is the set of elements of B union C? So we have circle B and then circle C. So what is the set of elements of B union C? Okay, so the set of elements of B union C are the letters. So B, G, M, O, E, H, K, C, J, D, or B, C, D, E, G, H, J, K, M, O. Next, what is the set of elements of B intersection C? Again, what is the set of elements of B intersection C? So the set of elements of B intersection C are the letters E and then H. Okay? Okay, so correct. Next, what is the probability of B intersection C? Again, what is the probability of B intersection C? Okay, while waiting for their answer, so if you are new to this page, please like and share our official FB page, Marcelo H. Del Pilar National High School. And don't forget to like and subscribe our YouTube channel, Teleradio Marcelo. Okay, so the answer is 2/15. Okay, Maggie Valerio, correct. Aliyah Ruda Crisanto, correct. Sophia Bernal, Florence Gale, Andrea Pia Bianca Laksa. So shout out to your mom, Ma'am Perla Laksa. And to all the grade 10 mathematics teachers. Next, what is the probability of A? Or what is the probability of an event A? Okay, so the probability of an event A is equal to 7/15. Since left side, A, so AIF 7/15 yung sample space. Next, what is the probability of an event B? What is the probability of an event B? Okay. So since we have BGHEOM dun sa circle B, so how many letters? 6/15. Or, okay, 6/15, Seth Gaspe, Rieza Bianca, B. Rarang, okay, 6/15, correct. What is the probability of A intersection B? Again, what is the probability of an event A intersection B? The probability of A intersection B is equal to 3/15. Since the intersection, the letters inside the intersection are M, O, and then E, so 3/15. Next, what is the probability of A union B? So in probability of A union B, it is equal to the probability of an event A plus the probability of an event B minus the probability of A intersection B, wherein our probability of an event A is equal to 7/15 plus the probability of an event B is equal to 6/15, so decreased by their intersection, which is 3/15. So 7 plus 6 equal to 13 minus 3. So magiging 10. 10/15 or lowest term. So divide by 5. 10 divided by 5 is 2. Then 15 divided by 5 is equal to 3. So we have 2/3. Okay. Correct. So Shaina, correct answer. Yen, Mateo, and Lexine, Josh, Diano, 2/3. Okay, so from that case, if two events A and B are not mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities decreased by the probability of both occurring. So, meaning, in not mutually exclusive events, these are the events that can happen at the same time. Or in symbols, again, probability of A union B is equal to the probability of an event A plus the probability of an event B minus the probability of A intersection B, wherein union may be read as or, then the intersection can be read as and. Okay? So this is for not mutually exclusive events. Again, an event that can happen at the same time. Okay, so another given Venn diagram. So just look at the two circles. So they are separate to each other. So circle A and then circle B. So what is the probability of an event A? So review pa rin tayo. What is the probability of an event A? So the probability of an event A is equal to 3/10. Since we have 3 letters inside the circle A. So we have AIE out of 10 letters as the sample space. So 3/10. Next. What is the probability of an event B? So what is the probability of an event B? So the probability of an event B is equal to 6/10. We have B, H, F, G, C, D. So we have 2, 4, 6 letters out of 10. Next, what is the probability of an event A intersection B? Okay, so the probability of an event A intersection B is equal to 0 since there is no overlapping circle. So, separate circle kasi sila. So, no intersection. That's why the answer is equal to 0. Next, what is the probability of A union B? So the probability of A union B is equal to the probability of an event A plus the probability of event B minus the probability of an event A intersection B. So their intersection is equal to 0. So probability of an event A is 3, and then probability of an event B is equal to 6/10. That's 9/10. So from that case, if two events A and B are mutually exclusive, then the probability that either A or B occurs is the sum of their probabilities. Or these are the events that cannot happen at the same time. In symbols, probability of an event A union B is equal to the probability of an event A plus the probability of an event B. No more subtraction because this is a mutually exclusive events. So example 1, a chip is drawn from an urn containing 4 distinct red chips, 5 distinct blue chips, and 6 distinct yellow chips. Find the probability that a red or blue chip is drawn. So what kind of event is this? Or is this a mutually exclusive or not mutually exclusive? So what kind of event is this? Okay. So this is an example of mutually exclusive event because there are distinct colored chips. So that's why we are going to use the probability of getting a red chip or a blue chip equals to probability of R or PR plus PB. So the probability of getting a red chip is equal to 4 over 15 since we have 4 distinct red chips. And then for the blue chips, we have 5 over 15 is equal to 9 over 15 or 3/5. So the probability that a red or blue chips is drawn is equal to 3/5. Okay? Next, example 2. A card is drawn from a standard deck of cards. Find the probability that the card drawn at random is a face card or an ace. Is this a mutually exclusive or not mutually exclusive events? Okay. So this is an example of mutually exclusive events because there is no ace in the face card and also in an ace card. So there is no face or face card. They do not have things in common. So again, we're going to use the probability of an event F or face card or an ace card is equal to the probability of an event of a face card plus the probability of an event A. So we have, for the face card, we have 12 over 52. Since we have king, queen, and then jack times 3, so times 4. So 4 times 3 is equal to 12. So 12 over 52 plus ace equal to 4 over 52. So the answer is 16 over 52. Or in simplified form, so the answer is equal to 4 over 13. Next, example 3. If 2 dice are rolled, find the probability of showing a sum of 7 or 10. So we have the given dice. we have 2 dice here. So we're looking for the probability of showing a sum of 7. So we have 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, and then 1, 6. Then the probability of showing a 10 is, okay, so we have 6 over 36. While the probability of showing a 10 are 6, 4, 5, 5, and then 4, 6. So we have 3 over 36. So 6 plus 3 is equal to 9. Copy the denominator. So 9 over 36 equals 1/4. Next, example 4. A chip is drawn from the urn that contains 4 red chips numbered 1 to 4 and 8 blue chips numbered 1 to 8. Find the probability that a red or an even numbered chip is drawn. Given, since red chips are numbered 1, 2, 3, and then 4, blue chips 1, 2, 3, 4, 5, 6, 7, 8, then the number of the set of elements for the red chips is equal to 4. So 1, 2, 3, 4. And then even numbers. So even numbers for red chips, 2 and 4. And then for blue chips, 2, 4, 6, 8. So we have 6. And then their intersection, number of set of elements of R intersection E is equal to 2. Okay, so they are the same for numbers 2 and then 4. So the probability of an event R union E is equal to the probability of R plus the probability of E minus their intersection. So we have 4 over 12 plus even numbers, 6 over 12 minus the intersection, 2 over 12. So 4 plus 6 is 10, minus 2, 8. So 8 over 12 is equal to 2/3. So the probability that a red or an even numbered chip is drawn is equal to 2/3. Okay. Next, example 5. A card is drawn from a standard deck of cards. Find the probability that the card drawn at random is a card. So is this a mutually exclusive or not mutually exclusive event? Okay, so this is an example of a not mutually exclusive because they can happen at the same time. Since there are King of Hearts, Queen of Hearts, and then Jack of Hearts. So meron ding face. Same with the face card. So meron tayo. So the number of set of elements for the heart card is equal to 13. So 1 to 10 heart cards plus the 3 faces, King of Hearts, Queen of Hearts, Jack of Hearts. And then for the face card is equal to 12. So 4 times 3. So we have King, Queen, Jack of Hearts, of Spades, of Diamonds, and then Clover. So 12. So the number of set of elements of H intersection F is equal to 3. So the probability of H union F is equal to the probability of H plus probability of F minus their intersection, since this is an example of not mutually exclusive events. So we have 13 over 52 plus, for the face card, 12 over 52 minus their intersection, 3 over 52. So we have 22 over 52 is equal to 11 over 26. Right. Example 6. If 2 dice are rolled, find the probability of showing a double or a sum of 10. So again, given the 2 dice, so we're looking for the probability of showing a double or a sum of 10. So showing a double are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, 6. So we have how many? 1, 2, 3, 4, 5, 6. So 6 over 36. And then for the sum of 10, we have 4, 6, 5, 5, and then 6, 4. So we have 3 over 36 minus their intersection in numbers 5, 5. So we have 1 over 36. So 6 plus 3, or 6 over 36 plus 3 over 36 minus 1 over 36 is equal to 8 over 36. So final answer, 2 over 9. Simplified form. Next, example 7. The Venn diagram below shows the hobbies of grade 10 students of Joms High School. So the hobbies are singing and dancing. So for letter A, how many students are there? Okay. So there are 138 students. So 48 plus 20 plus 57 plus 13, or the universal set. Next, letter B. How many students like singing? Okay, so the number of students like singing is equal to 68. So 48 plus 20. Next, how many likes dancing? So the answer is 77. So 20 plus 57 equals 77. Next, letter D. If a student is randomly chosen, what is the probability that he or she likes singing or dancing? Okay, so the answer is 125 over 138. So we're going to add the event for singing and then dancing, the union 48 plus 20 plus 57, and then over the sample space, 138. Example 8, the probability that Lawrence passes physics is 0.72 or 72%. And then the probability that he passes trigonometry is 0.65 or 65%. Suppose the probability that he passes both subjects is 0.54. Find the probability of the following. Letter A, he passes at least one of the subjects. Next, he fails trigonometry. And then he passes trigonometry but fails physics. So for the given Venn diagram, so event T for the trigonometry, passing trigonometry, and then event P for passing the subject physics. With their intersection, 0.54. Passes at least one of the subjects. So compute the probability of passing the subject of trigonometry union of passing the subject physics. So the probability of T is equal to 0.11 and then add the 0.54. So we have 0.65 and then for the probability of passing the subject physics is equal to 0.72 by adding 0.54 and 0.18. And then their intersection, so decreased by their intersection, 0.54 since we are looking for passing at least one of the subject. Okay, so 0.65 plus 0.72 minus 0.54 is equal to 0.83 or 83% that the probability of passing at least one of the subjects. Next, for letter B, he fails trigonometry. Okay, since for letter B, from the word fail or fails, so this is the event. This is not in the event. Since in our Venn diagram, the given is passing trigonometry and then physics. But in letter B, the word used is fails. Okay? So we need to use the probability of complement of an event. So the probability of the complement of an event, T or PT apostrophe or PT complement is equal to 1 minus the probability of passing the subject trigonometry. Okay? So 1 minus 0.65. So the answer is 35% or 0.35. So the probability of failing the subject trigonometry is equal to 0.35. So again, we need to use the complement of an event since failing the subject is not in the event in the given Venn diagram. Next, letter C. He passes trigonometry but fails physics. Okay? So the probability of passing trigonometry but not physics is equal to the probability of passing the subject trigonometry minus their intersection. So the probability of T intersection P. So our probability of T is equal to 0.65 minus 0.54 as their intersection. So the answer is equal to 0.11. Or upon looking the given Venn diagram, you will see the answer already. So 0.11 or 11% that he passes trigonometry but fails physics. So again, the probability of the complement of an event stated that the complement of an event is the set of all outcomes that are not in the event. This means that if the probability of an event A is probability of A, then the probability that the event would not occur, also called the complementary event, is 1 minus PA. So denoted by PA complement. So in symbols, we have PA complement is equal to 1 minus PA. So just what we did for letter B a while ago. So for the given Venn diagram, the complement of an event A is not in event A. Okay? So for the application, determine whether the events are mutually exclusive or not mutually exclusive. Then find the probability. Number 1, Mario has 45 red chips, 12 blue chips, and 24 white chips. What is the probability that Mario randomly selects a red chip or a white chip? So is this an example of mutually exclusive or not mutually exclusive events? Okay, so the answer is mutually exclusive event. Okay? Since the event cannot happen at the same time. So the answer is 23 over 27. Next, of 240 students, 176 are on the honor roll, 48 are members of the varsity team, and 36 are in the honor roll and are also members of the varsity team. What is the probability that a randomly selected student is on the honor roll or is a member of the varsity team? So what kind of event? Mutually exclusive or not mutually exclusive events? Okay, so this is an example of not mutually exclusive events can happen at the same time. So there is an intersection. So in the given, so 36 are in the honor roll and are also members of the varsity team. Okay, so therefore, this is a not mutually exclusive events. So the answer is equal to 47 over 60. Next, number 3. Carl's basketball shooting records indicate that for any frame, the probability that he will score in a 2-point shoot is 30%. A 3-point shoot, 45%, and neither 25%. So what is the probability that Carl will score either in a 2-point shoot or in a 3-point shoot? So what kind of event is this? This is a mutually exclusive events. Since this event cannot happen at the same time. So the answer is, just add the probability that he will score in a 2-point shoot, 30%, and then 3-point shoot, 45%. So 30 plus 45 is equal to 75% or 0.75 or 3/4. So I hope you learned a lot from the discussion. So if you want to know or learn more, just visit these references. Okay. Thank you to all grade 10 students who participated actively and joined in this discussion. And thank you also to our dear principal, Maria Victoria C. Vivo, and to Sir Marco Ronel M. Eusebio, our head teacher 6, Ma'am Cristina Piladeras, our scriptwriter, Master Teacher 2, Ma'am Serafia G. Calawag, Master Teacher 1, my co-teacher broadcaster, Sir Richard Martinez. Okay, so thank you. Again, I am Mrs. Jenity De Regla. Your teacher broadcaster is now signing off.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.